Alright, so looking over today's topic, we're talking about geometric sequences and how those apply with exponential functions. So the first thing we're going to do is we're going to pay attention to this definition that you see up here on the board. Geometric sequences. So a geometric sequence is when the ratio of any two terms or any term to its preceding term is a constant value. So what I mean by that, and what I'm talking about here, is simply that a geometric sequence is when we multiply each number by the same value. We're multiplying each number by the same value. Whether that value be a number that is a whole number or a number that's a fraction, we're multiplying each number by the same value. Now, a geometric sequence, underneath that, it says here that a geometric sequence has a starting value of a, and we want to say, since it's the starting value, let's go ahead and write this in. They kind of left that off. A sub 1. So the starting value is always a sub 1, and it has what we call a common ratio. Now, if you recall, in problems that we've talked about in the past, a common ratio or a common difference with arithmetic is very similar here, but a common difference adds the same number each time or subtracts the same number each time. With a common ratio, we're actually multiplying the same number each time. And it's going to follow the form of a sub 1, so the first term, and then we're going to take the first term and we're going to multiply it times r. Then we'll multiply the first number times r. Then we'll multiply that first number times r times r times r. So we're multiplying another number each time we look into the problem. And really, this information is a lot more complicated. It's a little bit more complicatedly explained here than what it's actually cracked up to be. So let's look at a couple problems, and then once we have those problems, we can go back and talk a little bit more about how this works, and it'll make a little bit more sense for you. So over here on the right-hand side where it says identifying geometric sequence, it says which of the following are geometric sequences. So in order to do this, we're going to need to be able to find one thing, and that one thing we're looking for here is r. Now there's a rule how to find r, or the common ratio, and the way we find the common ratio is take r and say r is equal to the second number in the sequence, or the second term, divided by the first term in the sequence. That's just kind of a given rule to help me find r, is to take the second term and divide it by the first term, and it'll tell me what r, or the common ratio, is. So with this problem, when we look at it, we've got 20, we've got 200, 2,000, 20,000, and then 200,000. So when we look at this to find the common ratio of this problem, we're going to take the second number, which is 200, and we're going to divide it by the first number, which is 20. So 200 divided by 20, we all know that divides out to give us 10. So in order for this to be a geometric sequence, we need to be multiplying by the number 10 each time in order for this to make sense. So first we're going to take 20 and we're going to multiply it times 10. And when we do so, we get the answer of 200. 200 times 10 is going to give us an answer of 2,000. 2,000 times 10 is going to give us an answer of 20,000. 20,000 times 10 is going to give us an answer of 200,000. So since we are multiplying by 10 each time, and we're multiplying by the same number each time, then what we can say is that, yes, this is going to be geometric. So that's basically how we work these problems, determine if it's geometric or not. So what I want you to do is I want you to take a second, pause the video, and I want you to go ahead and see if you can work that problem, and then go ahead and see if you can work the second problem. So work those two problems now. All right, so looking at the next two problems, I've already got them worked out up here for you, but we'll go ahead and do some explanation. So to find the common ratio here for the second problem, I took the second number 4 and divided it by the first number 2. So 4 divided by 2 gave me an answer of 2. So what that means is I should be multiplying by 2 each time. So what I did was took 2 times 2 and I got 4. 4 times 2 is going to give me 8. But wait a second. Is this an 8? No. So if it doesn't give me an 8, then I know that this is not geometric. So my answer here would be no, not geometric. Looking at the second problem I said that my second number here was -5. So I said -5 divided by 5. And -5 divided by 5 is going to give me an answer of -1. So in this problem, I'm multiplying by -1 each time. So 5 times -1 is -5. -5 times -1 is +5. 5 times -1 is -5. And then -5 times -1 is 5. So since this one works for me, I would say that this one is yes, geometric. So in this problem, I'm multiplying by the same number each time, so therefore it is yes, geometric. All right, go ahead and finish up taking your notes. If you need to make any corrections, do so at this time, and then we'll move down the page and talk about our next set of notes. All right, so looking into the second half of these notes, we're going to be talking a little bit about these two formulas. And we've talked about these two formulas in the past, the explicit formula. We've talked about the explicit formula, and then we've also talked a little bit about the recursive formula. So those are the two formulas we'll be talking about here. Now, if you pay attention, the only difference here, especially with this explicit formula, ignore all this over here. We're not going to worry about that part. But all you're going to notice here is that the formula is exactly the same as the other. The only difference is the R on the end. So for the recursive formula, the only thing we need to know is R. For the explicit formula, it's written a little bit differently, but with some of the same information. Here we have N, which is going to be the term number, or the number that we're looking for. R is still going to be the common ratio, which we already talked about how to find this, right? And then A1 is going to be the starting value. So with this problem, we're going to be dealing with the starting value and R, and then everything else will remain the same unless the problem changes. So in this problem, we want to be able to find the first term and R in order to set up our equation. So let's look at the first one, and all it wants to do is says find the explicit and recursive formulas for the sequence 7, 21, 63, and 189. So we'll start with the recursive formula. So to find the recursive formula is going to be written exactly how we see it here. The only thing we need to know is what the R value is. So to find the R value, we're going to say R is equal to the second term, which is 21, divided by the first term, which is 7. So 21 divided by 7 is going to give me the common ratio, which is what? 3. And then we need to also know a sub 1 for the explicit form here in a second. So what's the first term in the sequence? 7. So those two things are really easy to find. All we need to do is just set it up, figure out those two things. So with the recursive formula, we're going to use the exact same lingo, exact same formula. The only difference is the R. So here it's going to be a sub n. So we're going to write down a sub n is equal to a sub n minus 1. And then that's going to be times R. So R here is going to be 3. So we're going to write times 3. So that takes care of the recursive formula. That's all there is to working it out. The explicit formula is actually just as easy. Okay? The explicit formula is going to follow the exact same path, exact same track as the formula that we see up here at the top. The only difference is we're going to substitute a sub 1 in and R. So with this problem, we're going to write a sub n equals a sub 1, which we know a sub 1 is 7, times R, and we know R is 3, and then it's raised to the n minus 1 power. So we're going to write n minus 1 power. Once we write all that information down, we then have the answer to our problem. So with these problems, all we're looking to do is just write down the formula and then substitute in what we need to know. Keep in mind that the recursive formula is going to only substitute in R. The explicit formula is going to substitute in both a sub 1 and R. So as long as we know those two parts, we can figure out what our answer is going to be. Go ahead and see if you can do the next problem at the bottom here, and then work it out, and then we'll go to our last set of problems on this page. Alright, so looking at this problem, we found that with the sequence 2, 4, 8, 16, that our common ratio, and I wrote it up here at the top, so don't get that confused with the other problem, that our common ratio is going to be the second number 4 divided by the first number 2, and 4 divided by 2 gives me 2. Then I figured out the first term in my problem was going to be 2, so I wrote down the first term is 2. Now for my recursive formula, all I needed to do was substitute in R, so I've got a sub n is equal to a sub n minus 1 times 2, because the common ratio up here is 2. For the explicit formula, I took a sub n equals 2. 2 is the first term, so I wrote in 2 for the first term. Then I had times R. R is going to be the 2 as well, so I substituted in 2, and then I wrote to the n minus 1 power. So determining the explicit and recursive formulas for this problem was actually really simple, and I feel like a lot of people are feeling pretty confident about it. All right, go ahead and pause the video if you need to write any of this down, and then we'll look at our last set of problems for the last 4 minutes. All right, so for our last problem here, we're going to be using sequences in a word problem. So in this word problem, it says 2 managers at a clothing store created sequences to show the original price and the markdown prices of an item. Then it said write the recursive and the explicit formula for each. So just like we did a second ago, we're going to have to write down the explicit and recursive. And then it wants to know what will the price of the item be after the 6th markdown. So we're looking for the 6th number in the sequence. So to figure this out, first let's find the explicit and recursive. So for explicit and recursive, we need to know the first term, which here the first term it says is 60. And then we need to know the common ratio, which is going to be the first term, or second term, 51, divided by the first term, which is 60. So with this one, I'm actually going to get a fraction when I work it out, and I'm going to need a calculator to make sure I get the correct answer. So when I take in the calculator and do 51 divided by 60, I'm going to get an answer of 17 over 20. Now, I want to use that fraction in this problem. You can change it to a decimal if you want to, but I'm going to strictly use fractions for my ratios here. So to write the recursive, I'm going to abbreviate using an R. The recursive formula is going to be a sub n equals a sub n minus 1 times the common ratio, which is going to be 17 over 20. So when I have a fraction, I'm just going to write it as a fraction when I substitute in the R value. For the explicit value, I'm going to have a sub n is equal to the first term. So the first term here is going to be 60. And then that's going to be times, I can put parentheses around it if I want to, times the common ratio, which is going to be 17 over 20. And then I'm going to raise that to the n minus 1 power. Now when we get ready to find the 6th term in the sequence, we're going to use the explicit formula. So the 6th term means that I'm going to substitute 6 in for n. So that's going to be a sub 6 is equal to 60 times 17 over 20 to the 6 minus 1 power. So when I type this into my calculator, all I'm going to do is type in 60 times 17 over 20. And then I'm going to go back out. I'm actually going to simplify this 6 minus 1. 6 minus 1 is what? 5. So I'm going to raise it to the 5th power. And when I do that, I come out with an answer of a sub 6 is equal to, and since we're dealing with money here, it's going to be $26 and 62 cents. I round it if I can, but in this case I can't. So that's all I do for my problem. Now, understand, all I'm doing is substituting in a number here, and I'm working the recursive and explicit out the exact same way I did a second ago. So take a second, see if you can do the second sequence over here on the right, and then we'll check our answer briefly at the end of this problem. All right, so real quick, looking over the second sequence here, all we did was we found the first term of the sequence is 60. We found that the common ratio was 52 divided by 60, which is 13 over 15. So then when we did our recursive formula, we have a sub n is equal to a sub n minus 1 times 13 over 15. For our explicit formula here, we said that we had a sub n is equal to the first term, which is 60, times the ratio, which is 13 over 15 to the n minus 1 power. So to find the 6th term in the sequence, and that 6th is right there. substitute in the 6 for n, and then we said 60 times 13 over 15 to the 5th power in the calculator, and we got an